Hello friends, in this tutorial we will discuss about tiling a rectangle using squares. So let's consider the problem statement. Given an n cross m grid, we are supposed to tile it with minimum number of same size squares. And here n and m both are integers, and hence n into m is also an integer. So let's consider an example for better understanding of the problem. So let's say we have one grid is given 8 cross 12 and tile it. So here total we have 8 into 12, which is nothing but 96 number of squares we have, and we are supposed to cover all these squares using same size squares. So one of the possible solution is we can use 1 cross 1 square, and total 96 squares like of size 1 cross 1 are required in order to tile this entire rectangle. But our interest is in finding out minimal number of this type of squares. So here total 96 squares are required. So can we improve upon this? That is the question. So definitely if we increase the size of the square, then less number of squares are required. So for example, let me try with 12 cross 12 square. But in this particular case, if I take 12 cross 12 square, then ultimately I will cover 144 number of squares, but total number of squares are only 96. So we are covering more than what is required, so which is not allowed. So let me try with 8 cross 8. So if I take 8 cross 8 square, then ultimately this two columns will be covered using one single 8 cross 8 square. But now there is no way to cover these two blocks using 8 cross 8 square. So that means that this is also not allowed, and any combinations are also not allowed. For example, it's not allowed to take 1 cross 1 grid as well as 2 cross 2 grid as well as 3 cross 3 square and so on, right? So you can't merge different solutions in order to get a final solution. Only same size squares are allowed. Okay, so now from this it is very much clear that we need to consider a number which is common divisor of n as well as m. Okay, so 2 is common divisor, 1 is common divisor, 1 is trivial common divisor. So using 1 cross 1 we can definitely cover all those 96 squares. Now the second possibility is 2 is common divisor for 8 as well as 12. One more common divisor is 4. So definitely we are supposed to select the greatest common divisor. So divisor is required so that there is no extra covering or less covering. So we are supposed to cover exactly the number of squares or number of cells are given, right? So therefore it's necessary that whatever size we select, that size must divide n as well as m. Otherwise we won't be able to cover exactly what is required. So that is one thing. And second thing is we require optimality, right? For that we must select the greatest common divisor. So greatest common divisor of 8 and 12 is nothing but 4. So as you can see, using 4 cross 4 squares we can cover all the 96 squares. So that is the idea. So basically the input is 8 comma 12 and we are getting output as 6. So now we'll talk about Python implementation of this. So from this discussion we can say that the answer is nothing but n into m divided by GCD of n comma m whole square. So for example here n is equal to 8, m is equal to 12. So answer is 96 divided by 4 square, which is nothing but 96 divided by 16, which is nothing but 6. So in summary, the idea is if we use common divisor, then we can get a valid solution, but the objective is to get the optimal solution. So in order to get the optimal solution, we must choose a common divisor which is greatest, because the underlying idea is if we increase the size of divisor, that means if we increase the size of the squares, then less number of squares are required in order to tile the given grade. So from the previous tutorial we already know the code of GCD. Now we will extend this particular code in order to get the answer for tiling problem. So I am defining one more function. The name of the function is squares, and this function will take two arguments, n comma m, which is nothing but size of the grid. And now ultimately we will use the equation which we have just derived in order to get the result. So the idea is we are going to store m into n into variable a, and we will store GCD into b. But while computing GCD, we must make sure that the first parameter is greater than the second parameter. So for that we will use this particular condition. If n is greater than m, at that time we will call GCD n comma m. Otherwise we will call GCD m comma n. This is just to make sure that the value of first parameter is greater than the value of the second parameter, and in both the cases the answer will be stored in b. So ultimately, according to our equation, we just need to return a by b square, and our answer must be in integer, so that's why I'm using int here. And now this is the function. So now if we call this particular function, then we must get the answer. So let's try with our example. So answer should be 6. So it's 6. Now let me take one more example. Let's say 5, 25. So GCD is 5. So the answer is also 5. Let me take one more example. Let's say 100 by 10,000. So the answer is 100, and so on. Thank you. Subscribe to my channel for more videos.